So in this video, we're going to look at some special cases of validity and equivalence. Okay, so first of all, remember the definition of deductive validity. So an argument is deductively valid if and only if it's not possible for the premises of the argument to be true, but the conclusion be false, right? So if the premises of the argument are true, then the conclusion has to be false, right? You can't have the case where all the premises are true and the conclusion is false. And if the argument is not deductively valid, then it is invalid. Okay, so what happens if the conclusion is logically true? So look at this argument, right? Your premises are the moon is made of green cheese. This is an ASMR video. And then the conclusion is all dogs are dogs. Um, okay, by definition of validity, right? Argument is valid if it's not possible for all the premises to be true and the conclusion be false. All dogs are dogs is a logical truth. It's not possible for that conclusion to be false. If it's not possible for the conclusion to be false, then it's not possible for all the premises to be true and the conclusion be false, which means this is technically valid. Um, the premises have absolutely nothing to do with the conclusion, but the definition of validity doesn't actually require that, right? It doesn't require that there be any sort of connection between those. It just requires that it not be possible for all the premises to be true and the conclusion be false. And that is satisfied in this case. So this is technically a valid argument. Um, okay, what happens if you have a premise that is logically false? So there are dogs that are not dogs. Edmonton is the capital of Alberta, therefore the moon is made of green cheese. This is logically false, right? This is something that can never be true. Um, so, given that this can never be true, it's not possible for all the premises to be true of this argument. And if it's not possible for all of the premises of the argument to be true, then it's not possible for all the premises to be true and the conclusion be false, which means that again, this is actually valid, right? This also meets the standard for, or meets the definition for validity. So this is another, technically valid argument. Um, this particular instance here, right, where you have a premise that's logically false, is actually there's two of those. Is actually a general, or sorry, a special case of a more general, slightly more general phenomenon, which is what happens if the premises are inconsistent. So your premises of this argument are there are no cats here, there is a cat here. And then the conclusion is the moon is made of green cheese. These premises are inconsistent. It's not possible for both of them to be true at once. Since it's not possible for both of the premises to be true at the same time, it's not possible for all the premises to be true. So it's not possible for all the premises of the argument to be true and the conclusion to be false, which means that this is valid. Um, the case where one of the premises is logically false is a special case of this because if you have a premise that's logically false, any set containing that premise is automatically inconsistent. Okay, so those were a bunch of cases of special cases of validity. We'll then look at a couple of special cases of equivalence. Um, Remember that equivalence is so two sentences are equivalent if the same conditions make them true and false. Anytime one sentence is true, the other one has to be true. Anytime the one sentence is false, the other one has to be false, right? They always have the same truth value. So take all dogs are dogs and 2 plus 2 equals 4. These are both logical truths. Given that they're both logical truths, they're both true all the time, right? It's not possible for either of them to be false. That means that they're both true and false under the same, right, in the same the same situations, right? They're both true all the time and they're never false. So you can't actually have any situation where these two have different truth values. And what that means is they're logically equivalent. And this applies, in fact, to any logical truths, right? All logical truths are logically equivalent because they can never, I mean, the logical truths are always true. And since any two logical truths always have to have the same truth value, they are all logically equivalent to each other. Same thing is true for logically false sentences, right? If you had there are dogs that are not dogs and 2 + 2 = 5, both of those are logically false. There's no possible way that they can be true. Um, those then they are always false, right? Can never be true. So they will always have the same truth value, and they're all equivalent, right? They're going to be equivalent in all logically false sentences too, will be equivalent to each other. So these are special cases of logical equivalence.